2003 AP Calculus BC Form B number 2 graphing calculator question. Given the equation of two circles, find the area of the shaded region. Part A, set up an expression involving one or more integral with respect to x. So part A, we are taking that integration with respect to dx. X will be from, if you look at it here, this will be square root of 2 here. So if you look at as x goes, the top is changing. So we have to split into two parts, from 0 to 1 dx and 1 to square root of 2 dx. When x goes from 0 to 1, the top equation will be the equation of the circle 2. So we have to express the inside integrand as a function of x. So y squared equals 1 minus x minus y 1 squared, because y is positive. So y equals 1 minus square root. So this will be 1 minus x minus 1 squared here. And after 1 to square root of 2, the top function will be this piece, which is y squared equals 2 minus x squared, square root of 2 minus x squared. This is number 1. So part B, set up the equation in terms of y. So integration dy here. So if you look at here, as y value goes from 0 to this point, that point is 1, because it tells us intersection is 1, 1. So now integration from 0 to 1, right minus left. So the area is given by from 0 to 1 dy. The right function is the circle centered at 0. So x equals, because x is greater than x squared plus y squared equals 2. So x equals 1 minus y squared. Because x is positive, when we take the square root, it's give us positive here. Minus the left function here. The left function, x minus 1 squared plus y squared equals 1. X minus 1 squared equals 1 minus y squared. Be careful, everybody, here. Because x here is less than 1. From the left of 1. So when we take the square root, give us negative. So x here will be 1 minus y squared. This is our integrand here. Part C. So given r equals square root of 2, this is r equals square root of 2, r1 and r2 here. Find the area for this enclosed region. We can use polar coordinates too. The intersection here is pi over 4. So if we follow r2, that will give us integration 1/2 0 to pi over 4 r2 squared d theta plus 1/2 integration from pi over 4, follow this piece, follow r1 now, to pi over 2 r1 squared d theta. I think I switched r1 and r2. So this is r2. So first we follow r1. Then we follow r2. You can plug it in. 0 to pi over 4 r1 squared plus 1/2 pi over 4 to pi over 2 r2 squared d theta. So for each part is 3 points. 1 point for the limits, 1 point for the integrand here, 1 point for the integrand here. So 1 point for the limit, 1 point here, and 1 point here. Same thing for the part 3. The integrand, 1 point here, 1 point here. All the boundaries, 1 point.